Hey Dr. Lane, so I'm going to do a video reassessment on chapter 19. I picked a problem from the homework, and it's a circuit that's constructed from two batteries, and it gives you all the values and everything. I'm not going to read it out to you. I wrote them down on my paper. But the first question asks, what is the magnitude of the electric field at location F? So there's my circuit that I drew. There's all my values. And there's my energy conservation equation that I came up with from it. And it asks the magnitude of the electric field at F. So because they are made of the same material and the thickness is the same, the electric field throughout it will be the same. So it doesn't matter what location you pick it at, it's going to be the same throughout. So using that equation and the energy conservation equation, we could find that right there. And then the next question asks how many electrons per second enter the positive end of the battery at battery number 2. The top one's number 1, the bottom one's number 2. So we use the equation I equals N times U times A times E, which is electron mobility times electron density times area times the electric field. So we find our area. So we're going to get our radius squared times pi, and we plug it in because all the other values, like I said, were given to us right there. So we plug it in and we come up with 8.7 times 10 to the 18th electrons per second. The next part asks us if the cross-sectional area of both wires was increased by 2, what would be the magnitude of the electric field at F? Well, once again, if the area was increased by 2, it wouldn't really matter because the electric field will be the same. They're made of the same material. The area will once again be the same for both wires, so the electric field will stay the same throughout. So our answer was 5.38 volts divided by meters, which was the same answer as we previously got. And the distribution of XX charges, this wasn't a very great drawing that I had, but what I'm trying to show is that there's going to be, can't even find my finger, there's going to be more positive charges next to the batteries and less at the corners. So here be positive at these corners and next to the batteries by the positive end, and negative, once again more negative charges by the negative end of the battery and less at the corners. So that's my reassessment. Thank you.